Alrighty, boys and girls, it's time for Chapter 9, Section 6, Permutations. Okay, so a permutation is an arrangement or a listing where the order is important. For example, if you have a bunch of people, they're running a race, and you want to know how many different ways people can come in first, second, or third place, and so forth. So let's take a look at a couple examples. That's the best way to understand this. So here we go. Okay. So let's take a look at this example. Let's say Kay is scheduling her first 3 classes, and her options that she has to choose from are math, science, and language arts. So what we're going to do is we're going to use the fundamental counting principle, so think multiplication, to find the number of different ways Kay can schedule her classes. And when I say different ways, would you go math, then science, then language arts, or math, then language arts, then science, or maybe science, then math, then language arts, and so forth. So, when she chooses her first class, she has 3 different things to choose from: math, science, or language arts. So she has 3 options. Now, once she chooses one of these, it doesn't matter which one, for her second class, she only has 2 classes left to pick. So for example, if she chose math for her first period, she only has 2 things to choose from: science and language arts for the second, or whatever other scenario works. So we're going to put a 2 here. Now, once she chooses her second class, for her third class, there's only 1 class left to put in that position. So all we're going to do is we're going to multiply these. 3 times 2 is 6, times 1 is still 6, and that means that there's 6 different ways that she can schedule these 3 classes. Let's take a look at another example. Okay, so let's suppose at an ice cream store we've got 31 flavors there. Carla walks in and says, "I want a 3-scoop cone." Well, how many different 3-scoop cones could she buy if order is important? First, second, third, as far as the scoops. Well, when she chooses her first scoop, she's got 31 flavors to choose from. Then, once she chooses one of those flavors, she has 30 flavors left to choose for her second scoop. Then, when she goes on to her third scoop, she only has 29 flavors left to choose from. All we do is we multiply these 3 numbers together, and when we do this, we find out that she actually has 26,970 possible 3-scoop combinations if order is important. Pretty crazy, huh? Now, the next thing I want to show you is what this would look like if it was not a word problem. So right here, you see this P here? It looks like a probability question. Well, we also use this same symbol for a permutation question as well. So what this means is do a permutation, start with the number 31, and have 3 factors. And for this question, we started with 31 because there were 31 flavors, and it was a 3-scoop cone, so we did 3 factors. So this is how we would write this if it was not a word problem. Let's take a look at some more examples. Okay, so this next one. How many ways can 5 people stand in order for a picture? So if this wasn't a word problem, we would do a permutation. We're starting with 5 people, and we want them all to stand in order for the picture, so we're going to have all 5 of them in there, 5 factors. So the way this would work is as follows. We would have 5 times 4 times 3 times 2 times 1. Now, in case you didn't understand this, what we're doing is starting with the number 5, and we decrease by 1 as we go along. Whatever the second number here is, that's how many factors we have. And when we multiply these all together, we come up with an answer of 120. Okay, so next, suppose there's a race and it has 9 runners. In how many ways can the runners end up in first, second, and third place? So, if this was not a word problem, it would look like this. Permutation with 9. We're starting with 9. And we have 3 factors. First, second, and third place. We only care about the first 3 positions. So, to do this, start with 9. And again, 3 factors. So 9, then 8, then 7. Now, when we multiply all of these together, we end up getting 504 as the answer. So that means there's 504 ways that 3 of those runners can come in first, second, and third place. And in case you're curious, when the runners come in, Well, at first we have 9 runners that could get first. Once that first runner crosses the finish line, there's only 8 runners left that can get second place. And once that second runner crosses the finish line, there's only 7 left that can get third place. This is why it's decreasing by 1 each time. Let's take a look at a couple more examples. Okay, so here's 2 problems. They're not word problems. You know this is the number you're starting with. This is how many factors you have. Pause the video, try and do these problems. Press play when you think you have them. Okay, hopefully you set it up like this and hopefully you did well. Here we know we're starting with the number 13 and we have 2 factors, so 13 and 12. Here we're starting with the number 10 and we have 4 factors, so 10 times 9 times 8 times 7, 5,040. Let's take a look at another example that involves probability. Okay, so imagine you got a CD player, you can press a button and it'll play all the songs in the CD but in a random order. Now if there are 12 songs on a CD, what's the probability that the machine's going to play the first 3 songs in order? Well, this question, if it wasn't a word problem, would look like this. Start out with 12 songs, and how many do we care about? The first 3 in order. So, we have 12 times 11 times 10, and that's going to be 1,320. Now this right here, this is just how many possible outcomes there are, how many combinations there are of the first 3 songs, but we want to know what's the probability the first 3 songs will be in order. Well, that's one specific combination where it goes from track 1 to 2 to 3 exactly. So there's only one combination that has them in order out of the 1,320 possible combinations. So your probability would be 1 out of 1,320. And boys and girls, if you're good with all that, you should be pretty set for this section. All right, see you in class.